Okay, so we're going to look at what's called the quadratic formula. Oh, there we go. So this is what they call the quadratic formula. And what it does is it solves for x. And it solves for x when we're in the standard form of a quadratic. Okay. If you remember, there's a couple different forms, but this one is standard. So this is a standard form. And then you guys would have, that's much faster. You guys would have done something like vertex form would look something like this. Okay. Sometimes I highlight those letters. And then factored form is something like this. Okay. Now the whole point of this quadratic formula is to solve for really what x equals, or the x-intercepts when y is equal to 0. So you're really looking for x-intercepts, and this formula will help you solve it when you're in standard form, because it's really hard from standard form to find out what x-intercepts are. It's really easy in factored form to do it. Okay, so another benefit of this is you can kind of find the x-intercepts and then change into factored form using this. So there's lots of different things you can use this for. Normally the teacher will just tell you to use it to solve for x-intercepts, but there's a couple other things it can be used for. So we're going to go to a question, and what it does is, if you remember, you guys would have learned factoring before. So let's kind of build a question here. Let's say we have y equals 3x squared minus 2x minus 8. Okay, so I've just arbitrarily made this. So usually to find x-intercepts or to go into factored form, you would use factoring. Okay, and in this time your a value is greater than 1, right? So we got to use like a certain style of factoring. I think you guys use decomposition, right? So let's try decomposition. Let's bring this down. Y equals 3x squared minus 2x minus 8. Okay, so we need two numbers that are going to multiply, to what 3 times negative 8 is, which is negative 24. And those same two numbers got to add to our negative 2. So let's see. Oh, this actually ends up working out, I think. I'm thinking negative 6 and 4. Yeah, they work out great. I didn't want that to happen. Let's change this number. Let's make it 7. All right. Okay.
It's all good. Sorry.
So 3 times 7 would be 21. So this will make this a little more unreasonable. I would have thought arbitrarily I probably would have not made something that worked. Okay, anyways, two numbers that multiply to negative 21. Okay, well you got 1 and 21, and they're definitely not going to do negative 2. And then you just have 3 and 7, and they aren't going to make negative 2 either when you, that should be addition, when you add them. Okay, so what that means is we can't factor this. But it doesn't mean that it doesn't have x-intercepts or that there aren't answers for x. So when they taught you factoring, they only taught you like a select few when numbers are whole numbers, you know, when it's like 3 or 5. But what if it's like 2.666 and 7 and maybe 4.6666 as your answers? Those two would add up to this. But it's really hard for me to know those as factors of these numbers, right? So that's where factoring kind of fails us. But this helps us. Quadratic formula will factor it for us. It'll tell us what the x-intercepts are when x equals 0. So the only things we need to know is where our a is, and this is our a. I've already underlined our b, and this would be our c value. So if we know those three, we can then plug them into the quadratic formula from above. So x is equal to negative b. Well, our b value here is negative 2, so it's negative 2, plus or minus, and I'm going to talk about why it's plus or minus after. The square root of b again, well, b is again negative 2 squared, so we square it, minus 4 times a, the a value is 3, okay, and the c value is negative 7. And then all of that is being divided by 2 times a. 2 times, say it was 3 there. Okay, so all I did was I took our a, b, and c values and we plugged them into the quadratic formula. Those were the b's, these were the a's, and this is the only c in the formula. Okay, now you just kind of carry out bedmass. So we work with everything underneath this square root first. Okay, so x is equal to, and we can simplify this. A negative of negative 2 would just be positive 2. So we have 2 plus or minus the square root of negative 2 squared is going to be the number 4. Okay. Negative 4. So think of this like it is negative 4, because this could be really confusing at points. So negative 4 times 3 times negative 7. Okay. So when we put those all together, we'll put it in our calculator here. negative 4 times 3 times negative 7, there we go, is positive 84. So I'm going to put plus 84 here. So keep that in mind. If you include this as a negative value in multiplying, whatever this is, if it's a negative, you'd say minus that number. If it's a positive, you're going to say plus that number in the brackets, all right? So we're going to say plus 84 underneath the brackets. And then all of that is divided by the number 6. Okay, this will be root 88. So we're going to go 2 plus or minus square root of 88. Okay, so this is where it starts to get tricky. Square root of 88 isn't a whole number. We don't know it off the top of our head. So, do that after. Okay, here we go. Root 88. So 88 square root. Okay, so 9.38, and we'll round it to 2 decimal places, so 9.38. So we have x is equal to 2 plus or minus 9.38. So this is where we kind of address this plus or minus. Okay, so when we're talking about a parabola, if it has x-intercepts, there's a chance it has 1, but if we have a plus or minus here, it probably has 2. So that's why we're getting a plus or minus. We have to split the equation because we need to solve usually. If there are any x-intercepts, it usually occurs that there are 2 x-intercepts, okay? In order for there to be 1 when we root this, this number has to be 0, so it's kind of rare for it to happen. So there's going to be 2 of them. So we're going to split this equation into 2 different forms. We're going to do x is equal to 2 plus 9.38 over 6, and x is equal to 2 subtract 9.38 all over 6. Okay, so now there's 2. So we're going to solve for 2 of them, and again we're going to get some, funny values. This one's going to give us about 11.38 divided by 6. This one will give us x is equal to negative 7.38 over 6, and then whatever these are when we divide them. Let's find out what they are. Okay, 11.38 divide 6. 1.89. It's approximately 1.9. Okay, and the other one, negative 7.38 divided by 6, negative 1.23. That works out nice. So negative 1.23. And again, we kind of rounded before, so these are approximations. So these are the 2 x-intercepts, apparently, to this question. Okay. So obviously, when we factoring, we wouldn't know that 1.9 times negative 1.23 kind of work out to what we're trying to do. Okay. So what we're going to do is these are our 2 x-intercepts. Okay. So let's kind of show you what that would look like on a graph. 3, negative 2, and 8. And we're not using these. So 3x squared, squared minus 2x. Sorry, not negative. 7. Oh, we're really far out, so let's zoom in here. Here we go. Okay, let's change our graph. Make this 10. Nope. Negative 10 and positive 10. There you go. Much easier to look at. Okay, negative 1.23. That's right. That's one of the x-intercepts, and we said approximately 1.9, and that's what that kind of rounds to. So that's what it looks like. Okay. But remember we said the other thing you could do is you kind of put this in factored form. So now that we know these x-intercepts, okay, and that would pretty much be all you need to do with a quadratic formula, but like I said, you can do more. You can put it into the factored form of the equation. Factored form is y equals a x minus r, x minus s, so we say minus r minus s, and the r and the s are the x-intercepts, okay? And you can call either one r, either one s, it doesn't matter. So you say y is equal to a, and we say x subtract. Now this is a positive 9, but when we write it in, it's going to look like minus 1.9. Okay, and x subtract, and this one's a negative, so we have negative 1.23. So because we have 2 negatives together, okay, that will simplify to a positive. The only thing we're missing is a. And if we go way up to the top, we already know a. A is 3. So we can bring that value back down. So y is equal to 3. And then x minus 1.9. And x plus 1.23. Okay? And that should be the factored form. So if that's right, we should get overlapping parabolas on the other page. Now remember, we rounded just a little, but let's go over and try it out. 3x minus 1.9 and x plus 1.23. And check it out, they're overlapping. So now we're in the factored form of that. So even though it's not commonly used to do that, the quadratic formula, you can technically turn things into factored form with it, as well as finding x-intercepts.